Yeah.
Okay, Carlos, say hi to everyone on YouTube world because this is going to go viral. This video is going to go viral and you're going to make a lot of money. I know it. Say hi, Carlos.
Hi, everyone.
All right, very good. Who else wants to be famous? You're going to be YouTube famous. Let's see. Montserrat, you're going to be YouTube famous. This is going to go viral. Go ahead and say hi, Montserrat.
Hi.
There you go. Famous. Famous. Aaron, go ahead. You want to be famous, Aaron?
Sure.
All right, Aaron just went famous. Aaron, does anyone ever call you, like people call me AA Ron? Does anyone ever call you that?
Yeah.
Yeah, they get that. Have you ever seen that? You ever seen that skit where the guy's all AA Ron? Have you ever seen it on TV or no?
I haven't.
Oh, okay. It's pretty funny. He calls all these people weird names. Like, I don't know. I do with you guys, but then I'd probably get fired for calling you names what that guy called people. Except for, I think I could do AA Ron because I'm AA Ron. So I'm sorry, Aaron. I'm sorry, Aaron. I'm sorry. I didn't make you feel bad. I'm sorry. I won't do it anymore. I apologize. This is being recorded. I don't want to get fired. I did not say that. I did not call Aaron AA Ron because he is not. He is Aaron. Okay. Let's get on. Let's get on. See if this goes viral. I'm gonna be the. You guys ever see those teachers get videos and they go viral and they're on the news and then they get fired? I bet you'd like that to happen, wouldn't you? Hey, that's my teacher. He's on the news. He got fired. Woo! I knew that guy. Oxnard High School. Everyone's smiling. Stop smiling at it. I need to feed my kids. I have 4 kids to feed. You guys want me to lose my job? Jeez. Oh. Let's get to work. I hope I don't get fired. Okay. Oh, there's Patrick. Wait, I got the video of Patrick. The picture. See, he has no eyebrow, he has no teeth. Patrick has no teeth. And I think that's and he doesn't have the cape or anything. He's got kind of I've never noticed he has a belly button. All right. That's kind of gross. Okay. We are going to talk about the fundamental theorem of algebra. Okay, so our assignment, I don't know what page it starts on page, what page is this? Page 158. 3 through 41, every other odd. This is a crazy assignment. There's so much to do here, so I did change to every other odd because there's just so much to do. The topic, I got to get over here because of the glare. Look at that glare. The topic is the fun. Ow! Oh my! Ah! Radio! Oh! Oh! Dang! Ah! Whoa! What the heck just happened? Oh my gosh! My camera just went total radiation. Oh my gosh! Oh, okay, wait. Okay. Ah, oh, it burns. I gotta keep going though. Ow! Oh! The fun. Ow! Oh my gosh! Fundamental theorem. Oh! Ow! Oh! Hot! Holy, that radiation. Have you guys ever felt what the heck is there radiation? Is the world about to end? I don't know. All of a sudden, this radiation just started. Ah! Fundamental theorem of algebra. Oh my gosh! Ah! Oh! Oh my gosh! That was so hot. Jeez. Ah. Okay. Whew. Okay. I need my. This is like gamma radiation. You know, Bruce Banner became the Hulk. Oh my gosh! I hope it doesn't. Maybe. I hope I don't become the Hulk. I don't know what I would do. Ah! Oh, oh. Whew. Okay. The fundamental theorem of algebra. What is the fundamental theorem of algebra? The fundamental theorem of algebra basically tells us is based on the y equals 0 gives us the roots of an equation. Gives us the roots of an equation. So like, for example, if I have y equals x minus 3 times x plus 1, right? Well, I know that my roots are x equals positive 3 and x equals negative 1. And so the fundamental theorem of algebra just tells me what those roots are. They cross the x-axis at negative 1 and positive 3. And so it'll look like this. Negative 1 and positive 3. That's what the fundamental theorem of algebra is based on. And that's what we're going to talk about, is the different roots. Now we're going to figure out how to find the roots. We're going to figure out how many roots there are and all that stuff, starting with number 3. Boom. Let's do it. Stick around. Number 3 in our assignment. Okay. So let's look at, now, number 3. Identify the number of solutions of the polynomial equation. Find all solutions of the equation. Okay, so the fundamental theorem of algebra also tells us this. This is a third degree polynomial. Third degree. Because of the highest exponent is 3. That means there are 3 solutions. There are 3 solutions to this. Okay, now some are real, some are imaginary. Now, we can solve this by going like this, right? If I can solve this in 2 ways. One way will only give us 1 solution, okay? So how would I solve this? X cubed plus 64 equals 0. Let's go with Alonzo.
Yeah.
Hey, Alonzo, did you see my hands getting burned up, man?
Yeah, you okay?
Yeah, that hurts so bad. Did it happen to you? I don't know if it was like a worldwide thing. Did you get burned?
No, I'm good.
Okay, that's cool. I'm glad it's not just you. Okay, Angel Lopez.
Yes.
Hey, do you know how to solve this?
Um. X plus something parentheses X plus something parentheses X plus something.
Yeah, sort of. Yeah, you could do that way, but we could just do our basic algebra by just, right? If we just, yeah, very good, Angel. But let's go like this first. I can solve one way by subtracting 64 on both sides. You go on x cubed equals negative 64, and then taking the cubed root of both sides. Now, the cubed root of 64 is going to be negative 4. So there's one solution, but there's 3 solutions to this. According to my fundamental theorem of algebra, if it's the third degree, it has to have 3 solutions. I only have 1. X equals negative 4. But do you guys remember the sum of cubes? Sum of cubes, right? Remember, the sum of cubes is this. If I say a cubed plus b cubed, do you guys remember this? Is equal to a plus b times a squared minus ab plus b squared. Do you guys remember the sum of cubes? Remember we did that? We can use the sum of cubes. Brett, do you remember the sum of cubes? Wait, I don't know what you said. You just kind of said blah.
No, not really.
Oh, okay. Well, anyway, we talked about this before the break. I remember we did. the sum of cubes, if this is a perfect cube plus a perfect cube, then I could break it down like this. My sum of cubes was x cubed plus 64, right? So I take the cube root of x cubed, and that will be x. The cube root of 64 will be 4, okay? Then I take, right, the cube root of x and 4. Those are my cubes, right? A equals x, b equals 4. So then I take x squared minus 4x plus 16. Okay. Now again, to solve this, so this is this factored out. So remember, x plus 4 times x squared minus 4x plus 16. Everyone write this down. Equals 0. So how can I solve? Remember, there's supposed to be 3 solutions. Remember, 1, this shows me here that x equals negative 4, right? Because that'll be one solution, which is what we got. So we have one solution is x equals negative 4, which we said, because minus 4 to make this 0, 0. Now, the other way we can solve this solution is we can go like this. Solve this. Let's just look at this part right here. Let's just look at this part right here. And let's solve x squared minus 4x plus 16 equals 0. And we can go, let's do our little thing, 16 and negative 4. Can I factor it? No. I can't factor it because not two numbers equal 16 and add to negative 4. I cannot solve it. Okay? But I can solve this another way. What's another way I can solve this quadratic besides factoring? Brianna, what's another way I can solve it besides factoring?
Wait, can you repeat that?
How can I solve this for x, this equation right here, without factoring?
I'm not sure.
Brianna, who did you have for Math 2 last year?
Krieger.
Krieger is the man. He is the best. I'm telling you. Brianna, are you listening?
Yeah.
Did Krieger have you walking around campus singing a song?
I think so.
What do you mean you think so? Either you don't remember?
I don't remember.
You don't remember walking around campus singing a song? That means you probably did not. I thought he did. Didn't he have you sing a song? Dun dun na 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 na. You remember that song, Brianna?
Not really.
X equals what? Someone help Brianna. What's the song? Carlos, what's the...
Is it Quadratic Formula song?
Yes, X equals... I know Clay Camp made you guys run around singing this song. Who had Clay Camp?
Yeah,
Emma, you had
he
Clay
made us.
Camp, didn't you? Emma, didn't you have Clay Camp?
No, I had Krieger.
Did he have you run around singing that song?
I don't remember it.
What? Did he have you sing it, though? That's what I'm asking.
I think so.
Ethan, did you have Clay Camp?
I had Kruger.
Krieger?
Yes.
Ian, did you have... Who had Clay Camp? I know he made you guys run around. Ian, you had... Now you guys are going to deny it. Ian, who was your math teacher last year?
Krieger.
Julissa. Julissa,
Yeah.
who was your math teacher last year?
Yeah.
What?
Krieger.
No, I'm looking it up. You guys are all going to say Krieger now. Lorenzo, who was your math teacher last year?
Krieger.
No, it wasn't. Miley, who was your math teacher last year?
Clay count.
Oh, thank you for not lying. Not that Lorenzo was. I don't think anyone else was lying. Did they sing the song, Miley?
Yep.
Okay, do you remember it or no?
A little bit, yeah.
Okay, fine. Fine! All you kids, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Write that down. Write it down. Write that down. Write it down.
Wait, what's inside the square root?
Oh! Abraham, you saying I have bad handwriting? Because I do. Abraham, listening. X equals negative b plus or minus. Abraham, you looking?
Mm-hmm.
B squared minus 4ac. Can you read that now?
Yeah.
All over 2a. X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative b plus or minus square root b. Ow! Oh my gosh! Ow! Oh! I can't sing the song. It just burns. Ow! Both hands. Ow! Oh! Ah! Oh my gosh! Oh man! What the heck? Maybe I'm not supposed to sing the song. So let's go back to what we're talking about. We're trying to solve for all the solutions of x cubed plus 64 equals 0. Right? Trying to solve for all those. So we found one is x equals negative 4. Then we have this, right? So we factored out x equals negative 4. We have this, but I can't factor this anymore. So we're going to use the quadratic formula. So let's rewrite everything here where it's all neat for us to see. We said that x cubed plus 64 is equal to x minus 4. I'm sorry, x plus 4 times x squared minus 4x plus 16. I know that one of my solutions here, I'm going to write it over here, is x equals negative 4. But my other solution, I must use the quadratic formula to figure out this one. Okay, so we're figuring out the quadratic formula for this. Okay, what is my quadratic? Sorry, let's get all straightened out here. What is my quadratic formula? Okay, so I use the quadratic formula to solve this. I just rewrote this so you guys don't need to. So the quadratic formula is x equals negative b. Every time you write it, write a plus or minus square root b squared minus 4ac all over 2a will give me my other two solutions, because this says there are 3 solutions. So let's plug in our a, b, and our c. A equals 1. B equals negative 4. C equals 16. Okay? So let's plug in our equation. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And we plug in b equals negative 4. B squared equals negative 4. 4 times a is 1. 4 times c is 16. 2 times a is 1. And we simplify that. Sorry, we get it like that. I'm going fast because I have a feeling you guys just don't remember it, but now you're starting to remember it. Am I right, Billy? Have you seen this before? Or am I going too fast?
Yeah, I've seen it before.
Okay, I'm not going too fast?
No.
Okay, so I plugged in my a, b, and c into my quadratic formula to get my solution. Negative 4 is positive 4. Plus or minus negative 4 squared is 16. Negative 4 times 1 times 16 is negative 4 times 1 times 16 is, what is that? 4 times 64. All over 2. And then we say 4 plus or minus 16 plus 64 is 80. Am I right? 80 all over 2. And so my final solution is going to be 4 plus or minus 80. We could break that down even more. Let's take our 80 and break it down. 8, 10. Let me know if I'm just breaking this down. So you guys stop me if I'm, this is all review stuff, right? We can break 80 down. So, but stop me if I'm going too fast. I don't want to bore you. If you say, what the heck's going on, Sensei? Just stop me. Remember, we break this down all over 2. And then you don't take the square roots. 2 times 2 is 4. Wait, 1, 2, 3, 4. 1, 2, 3, 4. Right? So these square root of 4 is 2. Square root of 4 is 2. 4 plus or minus 2 times 2 root 5 all over 2. Right? Those are my two 2's that got out. 4 plus or minus 4 root 5 over 2. And then these are all divisible by 2. And then this will be 2 plus or minus 2 root 5 is my final answer. And those are my 4 solutions. I just solved using the quadratic formula. So I did that quick. I'm assuming you guys knew how to do that from last year. But my 3 solutions are x equals -4 and x equals 2 plus or minus 2 root 5. All right. How was that? That was a bunch of review. That's why I went fast. But if it's confusing, let me know. Hey, Samantha, was that confusing?
No.
Okay, that's cool. Thank you. How about you, Thomas?
I'm good.
All right. Are you just saying that or are you not just saying that? Are you saying that so I won't feel bad?
No, I'm getting it.
All right. Sam Adams, how about you?
Yeah, I get it for the most part, but how did you get a positive 64?
Oh, shoot. I made a mistake. Dang it, Sam. Why'd you show all my mistakes, man?
Well, I was going to tell you sooner, but I didn't want to interrupt you, so.
No, that's cool. No, it's cool. I was going fast, too. No, thanks for pointing it out. Okay, Sam is right. In fact, that does change things a bit here. Let me go through this. That mistake actually is important because let's go back. Can you guys see? Okay, -4 times +1 times 16 is actually going to be -64, right, Sam?
Yeah.
Minus 64. So dang, that's a big deal. 4 plus or minus 16 minus 64 all over 2. Okay, now what is 6? Okay, so what is 16 minus 64? I don't know. What is 16 minus 64? My brain's too tired. Anyone know it? Say it off the top of your heads.
48.
Is it -48? Thank you.
-48.
All right, cool. So 4 plus or minus square root of -48 all over 2. Can you get the square root of a negative number? Nathaniel,
No.
can you get the square root of a negative number?
No.
No, this is where you get an imaginary number, right? You ever heard of those, Nathaniel, the imaginary numbers?
Yeah.
So let's break 48 down. Yeah, well, anyway, I'll show you an imaginary number. You have seen it before, I'm sure. 4 is 2 and 2. 12 is 2 and 6. 6 is 2 and 3. So this will be 4 plus or minus square root of -1 times, here, let me know when I'm not showing my stuff. -1 times 2 times 2 times 2 times 2 is 48. 2 times 2 times 2 times 2 times 3. All over 2. Okay. So you take your square roots. Square root of 4 is 2. Square root of 4 is 2. So we'll say 4 plus or minus square root of 4 is 2. Square root of 4 is 2 times 3 times square root of -1, right? Square root of 3 is there. Square root of -1 is there. All over 2. Simplifying it. Can you guys see this? 4 plus or minus 2 times 2 is 4. Square root of negative 1 is I root 3. Remember, to take the square root of a negative 1 is I, and that's our imaginary number, and divide by 2. So our answer is 2 plus or minus 2I root 3. That's our answer. Now, because I have an I, that means that that is an imaginary number. And that is our second two roots. Two of them are imaginary. So our answers are going to be x, not this, but 2 plus or minus 2I root 3. Let me write that on a separate sheet of paper so that we can see. Let's look at everything all cleaned up. Okay, so x plus 64. What are the roots when it's equal to 0? Well, we said our solutions are x equals negative 4, and we said x equals 2 plus or minus 2I root 3. That means on a graph will look something like this. I got 1 crossing at negative 4 here. Whoops, that glare. You guys see? Oh, push everything over. I got one solution here at negative 4, and I have two imaginary solutions, 2 plus 2I root 3 and 2 minus 2I root 3. That means my graph will probably look something like this. It'll go through here. It'll have like a wave like that that will not cross. Here's a solution, there's a solution. It will not cross the x-axis. That means that it's going to have two little waves there. And those are our imaginary solutions. So there are 3 solutions, just 2 of them are imaginary. And that's that. What was that, number 3? All of that? So how did I solve this? I used the sum of cubes. I got negative 4, and then I used the quadratic formula to get these 2. Okay, that's all I did. Let's move on. Actually, are there any questions? That was a lot. Sam, thanks for pointing that out because we were able to see the imaginary solutions. Okay, let's move on. Skip 5. We're going to go to, let's go to 7. Okay, now let's skip 7. Let's go to 11, because this is a way to find the zeros. 7 you do the same way, and 11 you can do the same way too. So we're going to do 11 to show us how to do also 7. So 11 says find all the zeros. So you have to find the zeros, okay? G of x equals x to the 4th minus 9x squared minus 4x plus 12. Now this is called the rational roots theorem. Okay, we're going to use the rational roots theorem to find all of the zeros for this. Okay, the rational roots theorem. Okay, the rational roots theorem. The rational roots theorem is a way to figure out what makes these equal 0. Okay, it works when it's bigger than x squared. We have x to the 4th here. Okay, so here we go. Here's the rational roots theorem. Here's how you do it. You are going to take this, and it's not going to work. Notice how I'm missing an x cubed. If you don't have x cubed, it's going to mess you up. So let's write this as x to the 4th plus, how many x cubes do we have? 0x cubed minus 9x squared minus 4x plus 12. Okay, the rational roots theorem wants us to do this. Let's look at our first our last number, and our first number. Now there's a 1x. This is a 1, right? 1x to the fourth. Let's call the last number p and the first number q. Yeah, but what about the... Oh, I see. I thought it was soccer practice. Okay. So this is my p and this is my q. We want to find the factors of p and q. Let's find the factors of p. What goes into 12? Okay. So my factors of p are 1, 2, 3, 4, 6, and 12. Those are my factors of my p. What goes into p? 1, 1 times 12. What goes into p? 2, 2 times 6. What goes into p? 3, 3 times 4, 4 times 3, 6 times 2, 12 times 1. So for the rational roots theorem, in order to find the solutions of x when this all equals 0, we want to set it when this equals 0 is when we'll find our solutions. We find the factors of p. Now, what are my factors of q? Q is 1. 1 is 1. The only factor of 1 is 1. So we found our factors. Okay. I'm checking on you guys. Billy, how's this going? Am I making sense so far at this point? Even though you might not know what I'm doing. Do you understand the P and the Q?
Yeah.
Okay. How about you, Naveed?
Yeah.
It's making sense? Okay. You're not just saying that, are you, Naveed? Don't mess with me. Naveed, are you just saying that?
Oh, no.
Okay. Linda, how are you doing? Am I making sense so far about the P and the Q?
Yeah.
Okay. So all we have to do is find the factors of P and Q. All right. Now, to find, remember, we're trying to solve for x. So next, what we want to do, our next step, is we want to figure out what is P divided by Q. What is P divided by Q? So I take all my P's and I divide them by all my Q's. We'll only have 1 for my Q. So I go 1 divided by 1. Then 2 divided by 1. Then 3 divided by 1. Then 4 divided by 1. Then 6 divided by 1. Then 12 divided by 1, which is simplified. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6. 12 divided by 1 is 12. But guess what? The factors are also going to be positive and negative, because negative 3 times negative 4 equals positive 12. So they're going to be positive and negative. Those are all my possible solutions. Okay? P over Q gives all of my possible solutions. Not, some of these work, some of them don't. So we have to test them out one at a time. These are my possible solutions. Okay, so I'm going to start over here. So what are my possible solutions? Again, I'm going to rewrite the whole thing here. You don't have to rewrite it, because this is going to take a lot of room. Of x to the fourth plus 0x cubed minus 9x squared minus 4x plus 12 equals 0. What are my possible solutions? My possible solutions are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Whoops, there they all are. Sorry. Whoa. Okay, I just rewrote everything. Okay, so let's test them out. Let's test easy first. Positive 1 is going to be my easy solution. Let's try positive 1 first. And we're going to use synthetic division. Okay? So remember to do synthetic division? We have what number is in front of x to the fourth? 1. What number is in front of x cubed? 0. -9, -4, and 12. I'm going to pause. Star Trek. Star Trek. You guys hear that song with Star Trek? I actually got it from the Cable Guy when he's singing the Star Trek. This is before you were born. You guys don't know that. Okay. Synthetic division. I want to see if 1 works. I know if it works if I get a 0 for my answer. So let's do synthetic division. Bring down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -9 plus 1 is -8. 1 times -8 is -8. -4 plus -8 is -12. And 1 times -12 is -12, and I get a 0. Because I got a 0, then 1 is my solution. So I know that x equals 1. I got 1 solution. And when I divide it by 1, instead of being x to the fourth, 0x cubed, 9x, -9x squared, -4x plus 12, this is now x cubed plus x squared minus 8x minus 12. When I solve for 1, I divided it. That's my next one. So I figured out that 1 is my solution. Okay. Julie, Ian, did that make sense? How I figured out how 1 is my solution?
Yes.
Okay. With the how did I know it was my solution? How did I know?
Just using synthetic division, right? And knowing that you got a 0.
Yes. Because I got that 0 at the end. If it wasn't a 0, then it's not a solution, okay? Ethan, how did I know that 1 was my solution?
Because you got a 0?
Yes, the 0 at the end. Boom. Now, I want to try, even though since 1 worked, I want to try it again and see if 1 works again. Okay, so here's my next one. Let's try 1 again. Okay, so let's try it again. See if it works. You don't stop until it doesn't work. So you guys do this one with the 1. Do it with the 1, and you guys see if you can get 1. You guys let me know if it works. What are you looking for?
I'm looking for my new OT license. It's in an envelope.
Oh, well, there's this.
No, it's an envelope. It says from CBOT.
All right, does it work? I'm going to ask you guys. You're dividing it. I'm asking you right now. I'm looking at you, not presenting now. Let's see whose camera is off. Well, I've been bugging Thomas a lot. Thomas, I feel like I've been bugging you a lot, but I guess everyone is. Let's go like this. Everyone has their camera on. Okay, well, I'll just ask someone at random. Let's go with, does it work? Nathaniel, did it work?
No, he didn't.
Okay, it doesn't work. How about you, Brett? Did it work for you?
No.
All right. So it didn't work. So then what do? We try the next number, okay? Let's try the next one. Okay. By the way, let's see. Let me show you why it doesn't work. I got a 1. 1 times 1 is 1. 2. 1 times 2 is 2. -8 times 2 is -6. 1 times -6 is -6. -18 and -18, and it becomes -18. So it doesn't work. So we're done with 1. Forget 1. So let's start over again with these ones. 1, 1, -8, -12. We're still back at this. 1, 1, -8, -12. So let's do -1 next. -1. Okay? Here we go. See if -1 works. 1, -1, 0, 0, -8, and 8, and 4. So now I didn't get a 0, so -1 doesn't work. Okay. Well, -1, let's try +2 now. You got to keep going until you find an answer. 1, 1, -8, -12. Remember, this is x cubed. Sorry, this is x cubed plus x squared minus 8x minus 12. Let's see if 2 works. You guys try 2. You guys see if 2 works. Does 2 work? Come in.
I can use the car.
Am I going to use the car?
Yeah.
Like, what do you mean?
I'm gonna go drive to Claire's house.
You got your license?
Yeah. Are you in
What?
class?
I am.
Oh.
That's crazy.
Yeah.
Wait, hang on. Don't go yet.
Okay. Wait, get the keys on.
I do have my keys. Okay. My whole class knows you got your license now. Okay, my daughter got her license, everyone. So tell her congratulations. They're all saying congratulations. They're all clapping for you. They're all happy.
Thank you.
Look at that. Yes, they're happy. Okay, cool. You guys are clapping. Okay. All right. Angel Rojas, does it work?
No.
It does not work. Okay. How about you, Melissa? Did it work for you?
No.
Okay, so we'll try -2 next, okay? And then you keep going till see if they work. Okay? So I'm gonna do 2 just to make sure. So I got 1, 2, 3. 2 times 3 is 6. -8 times 6 is -2. And then we get -4 and then -16. So it doesn't work. So now let's try -2. 1, 1, -8, -12. Am I going too fast? Billy, am I going too fast for you right now?
No.
All right, thanks, Billy. -6. -2 times -6 is +12, and boom, we got a solution. -2. So I have here, my other solution is x equals -2. I'm going fast. How many solutions do I need, though? How many solutions do I need? I got -2. Linda, how many solutions should I have?
Four?
4 solutions, yes, because it's to the 4th power. I got 2. So we got 2 more to go. Now wait, I know what you're thinking. Oh my gosh, I got to do all that again? But no, you don't. Because look at, this is, remember this was x cubed plus x squared minus 8x minus 12. Well, now this is 1x squared minus x minus 6. And now I can just solve this. I don't need to do any of that anymore. Now you can just do your little factoring. And I got -3 and 2. And I have x minus 3 times x plus 2 equals 0. What are my last 2 solutions? What are my last 2 solutions? I'll let you guys look at that. I'm going to call in one of you. What are my last 2 solutions? Now that I don't have to do all that, I just figured it out by factoring. You guys see that? Okay, I'm going to call on you and someone in 10 seconds, unless anyone has any questions. All right. Who should I call on? Emma, what are my last 2 solutions?
Does it stay -3 and +2, or is it the opposite?
Let me answer that question with a question, okay? Which I know you guys hate. You want the answer to be 0, right?
Mm-hmm.
So how do I make this 0? What does x have to be?
A -2.
-2, and then how about this one?
A +3.
Yeah, so they're the opposites, but just so you know why, they have to make it equal to 0. The fundamental theorem of algebra says they have to be opposite to equal 0. So my 4 solutions are x equals 3 and x equals -2, which that popped up twice, which is fine. Whoops, sorry. Anyway, that was a long time. I have one more thing to teach you. You can watch the videos on that, but that's how you do that, right? So what do? You find the p and the q, and then you find the factors, and you go p divided by q, and then you synthetic division the crap out of it. You know what I mean? You just got to keep synthetic division all those so you get the answers until you could factor it and then solve. All right. Melissa, did that make sense?
Yeah.
Okay, that's a lot. Today's a crazy day. You have a test on Friday, guys. You have a test on Friday. I see you guys. I have one more thing to teach you, and then we'll be done. We've been here for an hour, and this is your 4th period. You guys are doing great. Oh. My daughter asked, all right, that's fine, Aaron. My daughter asked if she can drive to her friend's house. I don't know if I want her to. Should I let her go? I don't know. Okay, last thing. I don't know. What would you guys say if you're kids? Okay, what was that? That was 11, I think. Yeah, 13, 15, and then skip 17, and then 19. Okay, this says, okay, what are the instructions here? In exercise 17 through 20, determine the number of imaginary zeros for the function with the given degree. Okay, so remember, how many imaginary? Let me show you these. This one says there's 4th degree, so there's 4 total solutions. Look here, how many times did it intersect the x-axis? 1, 2. 2 real solutions. That means what's left over? There has to be 2 imaginary, right? Because there's only 2 real solutions. Look at this one. It has 1 real solution, but it says it's 5 degree. That means there has to be 4 imaginary. Okay, so real quick so we can get out of here. 19, it says 2 degrees. How many imaginary solutions are here on 19? How many imaginary? If it's a degree 2. Someone yelled out so I don't have to call in so we can get out of here. How many imaginary?
2.
2, very good, because there's no intersecting, but it has to have 2 solutions, so it's got to have 2 imaginary. Okay. Now, write a polynomial function, so 19, 21, 23. Write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. Okay, so what we have to do is write out 23. We have to write out this equation if I'm given these solutions, right? These are my roots, 3 and 4 plus I. So how would I write that out? 4 plus I. So it's going to look like this. 3 and 4 plus I. Here's how you'd write it out. Okay? Now remember, these are my solutions. My solution is 3. And now if I have 4 plus I as a solution, it also means, because I have an imaginary solution, it also means I have to have the conjugate 4 minus I. You switch the sign with the I. So I have 3 solutions for this. And so what is it going to be? My equation is going to be this. Solution is 3. So this has to be minus 3 because that makes it 0. Times x minus 4 plus I, x minus 4 plus I. Look at how I put those there. Times x minus, I subtracted from all of that. You got to put in parentheses. 4 minus I. So then I could take this, I can go x minus 3, let's clean it up, times x minus 4 minus I times x minus 4 plus I. And then what I have to do is I have to multiply all these out now. So I'm not going to multiply too fast. I'm not going to do the whole thing. I'll let you guys figure it out for yourselves. But if I'm multiplying it out, I like to do the boxes. X minus 4 minus I and x minus 4 plus I. And then you just multiply it out. I mean, I don't know if you guys need me to do this. Minus xi negative 4x plus 16 plus 4I plus xi minus 4I, and I times I is negative I squared, which becomes negative 1 squared, which becomes positive 1. And then these cancel out. The xi and minus xi and negative 4I and the 4I. So this becomes x squared minus 16x. 16 plus 1 is 17. So anyway, times x minus 3, right? So that times that, whoops. So then I multiply all those out to get the solution. I'll let you guys do that on your own. Are there questions on that? I did that. Basically, I just multiplied all that. You got to multiply all that out. Multiply all of that out. And I'm assuming you know how to do that, so. Okay. I'm going to test on Friday. Okay, last thing. That was 23, so we do 27. You can do that on your own, 27. Skip 29, and then do 31. Where's Descartes? I guess that's it. I feel like I showed you Descartes' rule. Oh, through 41. 31, and then 35. I was supposed to show you 35. We go to 41. Okay, Descartes' rules. The last thing. I'm sorry, guys. This is the last thing I got to show you. Then I'll be done, okay? So we got to do Descartes' theorem here. Determine the possible number of positive zeros, negative zeros, and imaginary zeros. Okay, so Descartes' rule is this. X cubed minus 4x squared plus 8x plus 7. Okay. G of x. Here's what Descartes' theorem says. Descartes' rule. It says this. It's going to let me know how many of my solutions are positive, how many are negative, and how many are imaginary. So we're going to do like this. We have here positive, negative, imaginary, and total solutions. Okay. Now, total is going to be 3. So I have a total of 3 because it's third degree. All right. Now, how many positive? You see how many sign changes there are. Okay, how many sign changes are there? Well, this is a positive. There's one sign change. And then here's two sign, positive, negative. There's two sign changes. So I have two sign changes with this regular function. That means there are going to be possible 2 positive answers. Or you take away 2 from it. You can only subtract 2, and there could be also 0 positive answers. Now let's figure out how many negative there are. The way we figure out negative is we got to go f of negative x. Got to plug in a negative into this. So this is going to be negative, negative x. Let me rewrite that. F of negative x. You put a negative, just put a negative in front of the x. Negative x cubed minus 4 times negative x squared. You guys see that? Plus 8 times negative x plus 7. So f of negative x is going to be negative x cubed is negative x. Negative x squared is x minus 4x squared. 8 minus x is negative 8x plus 7. And we figure out how many sign changes there are. So I just plugged in the negative x. No sign change. No sign change. And then 1 sign change. I only have 1 sign change. That means there's 1 possible negative solution, which means, and that's all. I can only subtract 2 from here. So then there's no because I have a total of 3, so that means if I have 2 positive and 1 negative, that means I got to have no imaginary. But if I have 0 positive and also subtract 2, 0 negative, that means I'd have to have possible of 3 imaginary, because these are the possibilities. I can have at least 2 or at least 0. At least 1. That's it. That's Descartes' rule. Okay, I just killed you guys. That is everything. We just went over an hour. Class ends at 3:30. If you have questions, you can stay. Otherwise, I'm going to let you guys go. You guys can go. If you have questions, you can stay. All right? I'll see you guys tomorrow. We're going to review the test. You guys are already going right now. I will see you. Bye, Connor. Love you, Connor. Bye, Alonzo. I love you. Bye, Miley. Bye, Nathaniel. Bye, Angel. Lopez. Bye, Thomas. Bye, Linda. Bye, Samantha. Bye, Brett. Bye, Sam. Woo. Okay. Bye, Carlos. I love you, Sam. All right. What are the okay? What are your guys' questions? Because I did go through a lot. It was crazy. Let's go with Melissa. Well, I don't know if Melissa's there. Let's go with Abraham first. What's your question, Abraham?
I have it's not really a question, but more that I didn't understand some parts, but also I didn't finish the last part for 35. I wasn't able to copy it.
Okay, let me get to that. Let's do 35 first, okay? That was a lot, man. Okay, so basically Descartes' rule says this. Every time I have a change, a sign change, that means how many solutions I have.
How do you know whether or not the sign changes?
Well, see how this is a positive?
Mm-hmm.
And that's a negative?
Mm-hmm.
Sign change.
Oh.
And then negative to positive, my second sign change. Right?
Mm-hmm.
And then positive, that's not a sign. They stay positive. It's not a sign change.
Mm-hmm.
So how many sign changes did I have?
2.
2. And then Descartes' rule says it's either that or you minus 2. So I can have 2 positive solutions or 0 positive solution.
Mm-hmm.
Angel, is this making sense to you too? That last part?
No, not a lot.
It's not?
Because I remember, like, the first question that we did today, I think we had, like, third degree. So we did 3 solutions. So
Yeah.
can
Well, wait, hang on. Angel, how many solutions can this one have? Look what I'm pointing at.
Oh, 3?
Yeah. Still, it's the same. But what Descartes' rule says is 2 of the 3 could be positive. You know, x can equal positive 3 instead of negative 3. He's just telling you if the answer can be, it's still 3 total.
Wait, how do you know that you know how you said that there's 2 changes?
Yeah.
Why is it under the positive instead of the other ones?
Well, I'll show you in a second. Keeping it the same, that's how we get the positive. And then I have to change it to a negative to find the negative. That's what I did over here. I made f of negative x. And I'll show you how to do that in a second. But if it is the way it is, you just count the sign changes. That's the possible positive solutions. Now, to change it to the negative, wait, let me make sure I got Angel first. Angel, do you understand the third degree or no?
Yeah, I got it.
Okay. Now this tells me the positive. What about the negative solutions? Let me rewrite it here. So we have here g of x, the way it was originally written, right? You guys understand? Is x cubed minus 4x squared plus 8x plus 7, right? Now to find the negative, what I have to do is I have to write g of negative x. I got to change the equation to that. Okay, this is how we find the negative, Abraham.
Okay.
Okay, so but what does that mean? That means you just put a negative in front of each x. So you take this, you put negative x, negative x cubed. That was that means. And then this is negative 4. You just change the x to negative. See how I changed that x to negative? Okay, and then it's going to be plus 8 times negative x, and then plus 7. Okay, so let's clean it up. So g of negative x, can you guys see what I'm doing here?
Yeah.
Abraham? Okay. Yeah. Negative x cubed would be, the cube makes it negative x, because odds are negative, right? You remember we talked about that yesterday? Evens are positive. So negative x squared would be positive x times 4. So negative 4x squared. And then 8 times negative x is minus 8x, and then plus 7. So now this will give me my negatives. I look at the sign changes. Abraham, do you understand how I got that?
Yeah. You just like made the x to a negative x, and then you just change it to everything.
Angel, are you with us?
Yeah. So since there was 2 changes in the regular one, that's how we got the 2 positive solutions?
Yes.
And since there was 1 change, it's 1 negative solution?
Yes. So this is my negative one, right? Let's look at the changes. Negative to negative, that's not a change, right?
No.
They go here to negative. That's not a change. And then look, there's only 1 change, that one right there, right? So I have 1 negative solution. Okay? Got it?
Yeah, I got it.
Okay. So I did this wrong. So what's 2 plus 1?
3.
3. And how many total solutions should I have? 3. So that means no imaginary, because 2 plus 1 already equals 3. Okay?
Yeah.
Now, Descartes' rule says you can subtract 2 to your total solutions. So I could subtract 2 here, and I could have 0 possible positive solutions. But I can't subtract 2 from 1, so I keep this as 1. This is 1. Okay. So ignore that. How many positives do I have here?
0.
And how many negatives?
1.
How many total?
3.
So how many imaginary should I have?
2.
2. So let's change this to 2. So my possible solutions are I could have 2 positive, 1 negative, 0 imaginary, or 0 positive, 1 negative, and 2 imaginary.
I don't get the bottom part. Like, so you know, like how the first half, like the top half, like you showed us right now how to do.
Yeah.
But I don't get the bottom half. Like, why is like
this part right here?
Yeah.
I don't know why, but Descartes' rule says I could subtract 2 from my first solution. So if I subtract 2, then I can also not only have 2 positive solutions, but I can have 0 positive solutions. It's just subtracting 2.
So wouldn't the other one be -1 since you're
You can't have any
2?
negative solutions. Like the number of solutions. I could have a negative answer, but I can't have negative. You know what I mean? Like I could have 1 negative solution. I could have 2 negative solutions. I can have 5 negative solutions. I can have a total of 0 negative solutions, but I can't have negative solutions.
Then wait, why does it stay so? For the negative solutions, is it going to stay the same? Like when you
Yeah,
put
it'll
the
stay
number
the
down?
same. It'll stay 1. Yeah, it'll stay 1.
Okay.
And so then you want them to add up to 3, and so that's how I get 2 imaginary solutions.
So the total for both, for the first half and the bottom half, are always going to be 3.
Yeah, because of this cube right here.
Oh.
Always has to be 3. If that was x to the 4th, then you'd have 4, and then these have to add up to 3, so then you'd have 1 imaginary, because they got to add up to this right here. This tells me how many imaginary solutions there are going to be. All right, you guys good?
Yeah. Or I'm not sure if he's.
I mean, I'm good for that question. I suppose the thing
right.
is, like, since you were going pretty fast, I was
was
just
going
like,
fast, man.
yeah.
That's okay.
Yeah.
All right, what's next? Okay, so let's go over probably 23. You probably need to go over, right?
Mm-hmm.
Yeah?
Yeah.
Did you need 23 or no?
Mm-hmm.
Okay. So 23 tells me that these are my solutions. Abraham, do you need 23 too?
Yeah, I was the one saying yes.
I mean, not Abraham. Angel, right? Is Angel there? Let me look. Angel,
Yeah.
did you? Okay. Okay. Okay, so these are my solutions. 3 and 4 plus I. Which one's my real solution?
3.
Which one is my imaginary?
The other 2.
Well, no, this doesn't exist. Just ignore that. Ignore it for a second.
Oh, okay.
4 plus I is my imaginary, right?
Mm-hmm.
Now, if you have 1 imaginary, you have to have 2. Okay? It's just a rule. because whenever you use the quadratic formula, it just ends up being that way. So if you have 1, then the other one's going to be the conjugate. So you know that this would be the other. You just put a negative in between the I and the number. So those are going to be your two solutions. All right, you got that so far?
Yeah.
Okay, so let me cover everything up here. If my solutions are 3, 4 plus I, and 4 minus I, that means my equation has to make this has to make my equation equal 0, right? So then one of my factors is going to be x minus 3. Because what is 3 minus 3?
The 3 minus 3, that'll
Yeah.
be 0.
Yeah, so that's what I want. So you want to make something that makes this equal to 0. And that's where I got this. It's basically the opposite of what this is. So this is the solution. So it's going to be x minus 4 plus I. That's how I got that one. And then you do this one, x minus 4 minus I. Whatever the solutions are, it's going to be x minus that solution, x minus that solution, and x minus that solution. You guys get it?
Mm-hmm.
Yeah.
Okay. So now I have so look at it's x minus 3 times x minus 4 plus I times x minus 4 minus I. To find you just multiply all those together. So what I did is I multiplied this, x minus 4 plus I times x minus 4 minus I. I just multiplied those together. And I went like this. I distributed the negative. So this would be negative 4 minus I. I just multiplied the negative out there. And then I distributed the negative here, negative 4 plus I. And now I'm going to say x minus 4 minus I times x minus 4 plus I. And I did it here. X minus 4 minus I times x minus 4 plus I. I multiplied them here. And I went x times x is x squared. X times negative 4 is negative 4x. X times negative I is negative xi. Negative 4 times x is negative 4x. Negative 4 times 4 is positive 16. Negative 4 times negative 1 is positive 4i. I times x is xi. I times negative 4 is negative 4i. And I times I is negative I squared, which is I squared is negative 1. Negative 1 times negative 1 is positive 1.
Wait, how do you do the bottom right
So
corner?
1? How do I get this one?
Yeah.
Okay. Look it. Did you know that I squared is equal to negative 1?
Yeah, I think so. But it's like when it's in the square root, that's how it becomes I, right?
Well, I is equal to square root of negative 1.
Yeah.
So if I took I squared, it's the square root of negative 1 squared. And the square and the square root cancel out. So it's really equal to negative 1. Anyway, it doesn't matter. I squared is equal to negative 1. That's all you need to know.
Okay.
Okay? So this is negative I squared. Negative I squared. What I say I squared is equal to?
Negative 1.
So negative 1 is positive 1. And that's how I got the positive. Good or no?
Yeah.
Okay. So now I multiplied all these out. I have x squared. I got that. Negative 4x. Oh, I'm sorry. Negative 4x minus 4x is actually 8x. This should be 8x. And then 16 plus 1 is 17. Then I need to take x minus 3 times that. And I got to see that there's my answer. Now you have to multiply these. And then you get your final answer.
And you can multiply them doing another square, right?
Yeah. Do you want me to do it?
I think I could manage it.
I could do it real quick.
Yeah. All right.
All right. Angel, are you still there?
Yeah, I'm still here.
All right. All you do is just go x squared minus 8x plus 17, x minus 3. Abraham, let me know if I'm going too fast, okay?
Okay.
Am I going too fast?
You're doing fine.
Okay. X times x cubed. X times negative 8x. Right?
Mm-hmm.
What goes in here, Abraham?
17 gets.
And then negative 3x squared. Negative 8 times negative 3, 24x. And negative 3, what's negative 3 times 17? You guys got a calculator? 17 times 3.
51, right?
51. So it'll be negative 51. And so, combine x cubed, negative 3x squared minus 8x squared, negative 11x squared, 24x plus 17x. I want to say 41x. Is that right? The 41?
Think so.
Yeah, 41x minus 51. Call that f of x. All right. How you guys doing?
Good.
All right. Any others?
Yeah, I'm sure I have questions for like all of them, but like I think it'll make more sense if I do one or something.
There's a lot, man. There's a
Yeah.
freaking lot. It's okay if you. No, we'll do a test review tomorrow.
For 11, I got how we got x equals 1 and x equals negative 2. But I didn't understand the rest.
Oh, I lost my 11. Let's see, where's that one? Oh, here it is.
Wait, we did 11 together? Wait, did we do 11?
Yeah, I found it.
We did 11 together?
Yes, yes.
Hmm.
That was a long one.
Perhaps I put it as. Wait, did we do number 9? I think I might have like switched number.
This one right
numbers.
here. This is the one I have for 11.
Oh, I wrote it as number 9.
Right,
Oh.
Abraham? Is this the one?
I mean, I have it as number 9, so maybe I have.
I mean, Angel. I'm sorry, I'm getting you guys confused. I mean, Angel. Is this the one you referred to?
Yeah.
Okay. All right. So I'll just walk you through everything. I'll go kind of quick because I think you understand. Then we'll get to your question. So we're trying to find the solutions of this, right?
Yeah.
Okay, so what we do is we're going to find our possible solutions. I call this P, and I call this Q, right? Then I want to find the factors of 12, which is my P, which is 1, 2, 3, 4, 6, and 12, right?
Yeah.
Okay, and then my factors of Q are 1. And then I divide them, P over Q, 1 over 1, 2 over 1, 3 over 1, 4 over 1, 1 over 1, right? And I get plus or minus 1, plus or minus 2, plus or minus 3, plus. These are my possible solutions. All right? Angel, do you understand how I got the possible solutions?
Yeah. Yeah, I got that
Okay.
one.
Abraham?
Mm-hmm.
Okay. So Angel, you're asking how I got 1 or negative 1. I got 1.
Can I see the answers you got? Because I know I got.
These are my answers: 1, 3, negative 2, and negative 2.
I just did 3 and I understand that one now, but I don't get how you got 2 negative 2s.
Oh, well, first of all, let me answer that. This is kind of not a quick question to answer. My first negative 2 I got from this by dividing negative 2, right?
By dividing negative 2. What do you mean by dividing negative 2?
Well, here, right here, look here. Remember I did the synthetic division?
Oh, yeah.
So I brought the 1 down times negative 2. This is technically I'm dividing here, right? Synthetic division. And I got 0, right?
Yep. Yeah.
Okay, so that's how I got that negative 2. That's how I got this first one. Is my answer. Once it's 0, I know that's my solution. Because you understand that?
Yes.
Okay. Then, once I divided it, this is a quadratic. It ends up being x squared minus x minus 6.
What is it? X squared minus x minus 6? Oh, yeah, yeah.
So
1x squared minus 1x minus 6. Every time I divide it, this number gets smaller, right?
Yeah.
Okay.
I get it.
Okay. So now I just factored this and I got x minus 3 times x plus 2 equals 0. And so my solution, wait a minute. Yeah. My solution is going to be positive 3, because that makes it 0, and negative 2, which is, I have 2 negative 2's for my answer.
Oh, okay.
So I think what's confusing about that is, first of all, let's break this down one thing at a time. Do you understand how my answer is negative 2 for this right here? Just that
yeah.
It's, okay, because go ahead. Go ahead.
Oh, because of the x plus 2?
Yes. Now, what you might be wondering is, how the heck can you have negative 2 as your answer twice? Is probably what you're saying, right?
Yeah.
So what's going on here? My original question was this: x to the 4th plus 0x cubed minus 9x squared minus 4x plus 12 equals 0. I said my answers are 1, negative 2, 3, and negative 2. Well, what I kind of did here with my solution is I actually found solutions by factoring. If I was to factor this out, it would be equal to x minus 1, because 1's my solution, right? Times x minus 3, because 3 is my solution, right? Yeah. Times x plus 2, because negative 2 is my solution, and then negative 2 is my solution again, x plus 2 equals 0. So this equals that. Or another way to write it would be this: x minus 1 times x minus 3 times x plus 2 squared. All it's showing is that I have 2 factors of x plus 2. That's what that's showing.
Oh, okay.
So technically, x minus 2 is really, there's only one answer of x minus 2. But since I solved it twice, I needed to find 2 roots. It means it's going to have an x plus 2 squared in it. But really, you're right. There is only one x minus 2. But this allows us to see this. It's
Okay.
kind of like saying, do you get it?
Yeah, I got it now.
Okay.
I have a question about that question.
Sure.
So when we were doing it at first, it was 5, right? Like you were dividing 5 numbers in the synthetic division,
Yes.
and then it dropped down to 4, right?
Yeah. Yeah.
Wait, why did it drop down to 4 numbers instead of 5? Like where did that
Because every
happen?
time you divide it, it gets smaller. It's kind of like saying, I mean, I think you're overthinking it, but it's kind of like saying if I go 100 divided by 10, right?
Mm-hmm.
My answer is 10.
Yeah.
You don't ask me, hey, sensei, why is there 2 digits in that answer?
So when we found out that which one was it? When we found
Whenever
out
you,
that
whenever you divide, your answer becomes smaller than the quotient. It's going to be smaller. And go ahead, Abraham, and then I'll show you one more long way to show you what it is. But go ahead. What are you going to say?
So I was like, so the reason why, and the so when it went to 4 numbers, it was when we found out the first x, right? Which was 1.
Yes. Yes.
Oh, it was
Synthetic division is doing this, but shortcut wise. Remember, like I go, okay, this is x to the third, right? Remember how we did regular division?
Mm-hmm.
So when I divide it, right, what I'm doing is I'm really doing this, but shortcut. This becomes x to the fourth minus 1x cubed. And then I subtract, right?
Mm-hmm.
This becomes x squared minus 9x. X cubed minus 9x squared. Okay, so what should this equal? What do I multiply x by to get x cubed?
X. Oh,
No.
x squared.
So I say plus x squared, x cubed minus x squared, and then I subtract it. And this becomes 8x squared minus 4x. Okay, what should I multiply by to get 8x squared now?
8x.
8x. 8x squared minus 8x. Subtract negative, positive, 4x. Oh, I should have done x plus 1. Dang it.
Oh, we can't see it. Oh, okay, there.
Hang on, I'm redoing it. X to the fourth plus 0x cubed. Yeah, minus 9. Let's start over. Okay, so this has to be x to the third. So this will be x to the fourth plus x to the third. Then I subtract negative, negative. This becomes negative x cubed minus 9x squared. So now I got to multiply by x, negative x squared. Negative x cubed minus x squared. Can you see? No? There you go. Subtract. This becomes plus, plus, plus. This becomes 8x squared minus 4x. So what do I multiply by now, Abraham, to get rid of this 8x cubed?
Well, 8, right?
8x, right?
Oh, yeah, yeah.
8x squared plus 8x subtract negative 12x plus 12, right?
Mm-hmm.
What I multiplied by, Abraham?
Negative 12.
To get negative 12x, what do I got to do?
Well, negative 12, right?
Negative 12x should work. What did I do wrong? Wait a minute. Oh, this, wait. Why did it not work? Hang on. One of these I messed up on.
It's fine. It's like I get it.
Oh, so you see, but my point is, so this should have been, my point is, I made a mistake somewhere in all this, but my point is, you don't ask me, hey, sensei, this has 1, 2, 3, 4, and when this one has 5, right?
Yeah.
That's what you're asking me.
Yeah, I see the mistake that I did. I forgot to get rid of the 0 after getting the first one.
I think this one I should have made it. This should have been negative 8x squared. This one should have been negative because that should have been. I think that's where my mistake was. But anyway, okay. So does that answer your question?
Yeah.
Okay. You guys have any other questions?
I don't think I have a question for number 3. I feel like if I just like go through the first question and just like see how we do it. But hopefully not.
Hey, listen. If you get it wrong, I'm not going to mark you wrong on your homework. You know what I mean?
Yeah.
But it's good that you understand. But don't stress about it getting it wrong for wrong's sake. Right? You're not stressing about that.
Yeah.
Yeah or no? Yeah,
No,
you are
but
stressing about it?
Oh no. I'm just like trying to figure out how to do it for the test.
Good. Angel, do you have any other questions?
No, I think I can figure it out. The last one.
All right. All right. I don't know how you guys have the energy to do all this. You're just stud math students willing to go to the end. Abraham, how many classes? Do you have a first period?
I don't have a first period.
Okay. Did you have a second period?
Mm-hmm.
Third?
Mm-hmm.
Did you go all day in class? Or do your other classes?
No, like we finished relatively early for them.
Okay. Well, that's good. I don't know. How about you, Angel?
I didn't have a third.
Oh, yeah? Why not?
I don't know. I think she has
What do you mean you don't know? Wait, what?
She has like office hours, so I don't know.
Oh, what class is that?
World history.